Next we have question number 9, factoring a polynomial given a non-zero. The function f of x is given, we have to factor it given that negative 5 is a 0. So I'm going to, before even start the problem, use this fact. So if negative 5 is a 0, that means f of negative 5 would be 0, right? And x minus 5, which is x plus 5, is a factor of f of x. What does that mean? That means if I divide f of x by x plus 5, let's divide that and I'll show you what it means. So we have f of x whose coefficients are 3, 25, 42, negative 40. We have to write negative 5 here. 3 comes down, multiply by 5, negative 5, it's negative 15. Add the column 10, negative 50, we have negative 8. Multiply negative 5 and negative 8, we get 40. We add, we get 0. We knew that we have to get 0 because this was given, right? But what is the quotient? Quotient is this polynomial. This polynomial is going to be 1 degree less than the given polynomial. So this is going to be coefficient of x square, x and constant. So we can say f of x is equal to x plus 5, which was the factor, times what is the quotient? 3x square plus 10x minus 8. Now, I already have one factor x plus 5. The remaining is a quadratic polynomial. I can factor that easily. That would be, factorizing this, I would get 3x plus 2 times x minus 4. So we have factored f of x. That was the first part of the question. Using the fact that negative 5 is a 0, factor the function, solve this equation. It's the same. Look at this. This is the same as the function. That means we have to solve f of x is equal to 0. What is f of x? X plus 5 times 3x plus 2 times x minus 4 equal to 0. That means either x plus 5 will be 0 or 3x plus 2 will be 0 or x minus 4 will be 0. So we have x is equal to negative 5 from here, negative 2 by 3 from here and 4 from here. So these are the solution sets of this equation f of x is equal to 0. So you see how the fact that we know the synthetic division and we know the factor theorem, we know that if negative 5 is a 0 of the function, then x plus 5 will be a factor, right? If x plus 5 is a factor, we can find the quotient, and that quotient we can factor it further, which will help us find all the zeros of the function. Let's look at our last question. Write a polynomial function of degree 3 that has zeros 2, square root 6 and negative square root 6. Now, if it is a polynomial of degree 3, it has a 0, 2. That means x minus 2 will be a factor. It has a 0 square root 6. It means x minus square root 6 will be a factor. It has a 0 x minus negative root 6. That means x minus root 6 will also be a factor. So we say x minus 2, that means our polynomial would be something like x minus 2 times x minus root 6 times x plus root 6. We can simplify that as this: a minus b times a plus b, x squared minus 6. This can be distributed, x cube minus 6x minus 2x square plus 12. So in the standard form, my polynomial is plus 12. This polynomial has the zeros 2, root 6 and negative root 6 because of the factors here.